Good afternoon. We are going to take notes on day 12 of chapter 6, Quadratic Story Problems. Now, the story problems I'm going to use on today's notes are on a PDF, Quadratic Story Problems. If you haven't had a chance to download this and print it, I would go ahead and do it because I'm not going to take the time to write the problem out on each one that I do. So pause the video, get the Quadratic Story Problem page, and then restart. Okay, problem number 1. You are constructing a frame for the rectangular photo shown. That's not shown, 12 inches by 17 inches. You want the frame to be the same width all the way around, and the total area of the frame and photo to be 315 square inches. What should the outer dimensions of the frame be? Okay, so that's the basic problem. It's a photo with a frame. Okay, we are constructing a frame for a photo, which is 12 inches by 17 inches. So we're going to start by drawing this. So 12 by 17 usually means a little bit wider than it is tall. So this is 15 inches, this is 12 inches. And we're going to make a frame around it that is the same width all the way around. So I'm drawing a frame. And we know that the total area of the frame and the photo is 315 inches square. So total area is 315 square inches. So we're trying to figure out what the outer dimensions of the frame should be. So we're looking for the width and the length, or the length and the width, doesn't matter. Okay, so here's the trick to doing frame questions. The trick is that the width of the frame not just adds on to one side, but it adds on to both. For example, if I'm looking at width, I'll have 15 inches, and I'll have a little bit of frame here. We'll call that X inches wide. But I have a little frame over here too. So actually the width is 15 plus X, because you have the total width of this will include two pieces of frame. The same thing goes with the length. Yes, we have 12 inches, but we have a piece of frame here and a piece of frame here. So the length is going to be 12 plus X, because you have a piece on the bottom and a piece on the top. Now you have to find a way to relate these two to each other, something they're equal to, so you have something to solve. Well, the total area was 315, and of course the area of a rectangle is length times width. That's your formula. So I'm going to take these two quantities and I'm going to put them into an equation. 315 equals length, which is 12 plus 2x, times width, which is 15 plus 2x. And I'm going to actually solve for x. Okay, so first thing we have to do, because these aren't the same, you can't just take square roots, we got to multiply this baby out. So 315 equals, let's see, 12 times 15. Oh, it should be 17. Sorry about that. 17 inches, my apologies. So this one should be 17 inches, and I am definitely going to grab a calculator to help with some of these bigger numbers. Okay, 12 times 17 is 204. Then I have 12 times 2x, which is 24x. 17 times 2x, which is 34x. And then I have 2x times 2x, which is 4x squared. So it's obvious we're going to have a quadratic here of some kind, and you solve quadratics by making them equal to 0. So I'm going to move everything over to the right and simplify. So I'm going to subtract 315 over to the right. And then I'm just going to flip-flop my sides for convenience. So that gives me 4x squared plus 58x minus 111 equal 0. Okay, so at this point, You can try to factor, but I wouldn't recommend it. You can also use quadratic formula or completing the square. Probably quadratic formula would be your best bet. So you would go to quadratic formula. So remember, quadratic formula, x equals -1 times b plus and minus the square root of b squared minus 4ac all over 2a. Okay, let's do it. X equals -1 times 58 plus and minus the square root of 58 squared minus 4 times -111 all over 2 times 4. So we simplify. You get -58 on the top, 8 on the bottom, plus and minus. All right, I'm going to start using my calculator. 58 squared is 3,364 plus 111 times 16, 1776, because a negative times a negative is a positive. So I'm going to add these two together. So plus 3,364, that gives me -58 plus and minus the square root of 5140 all over 8. Now here we have two different possible answers. However, x is supposed to be a length. If I take -58 minus whatever I get, I'm going to get a negative value. So even though you technically get a positive and a negative side, there are no negative lengths. So the negative side gets to be disregarded. All right, well, let's do this. The square root of 5140 is a decimal. That's not a shock. Minus 58, and then divide it by 8. You get x equals 1.711, or 1.7 inches. Okay, so the goal was to figure out the dimensions of the frame. What should the outer dimensions of the frame be? Okay, so keep in mind, back here, it is 17 plus x plus x. So the width is 17 plus x plus x. So I'm going to take my decimal in my calculator. I'm not going to truncate it. I'm going to make it 1.7117. Square it. Sorry, 1.717. Delete. So 1.7117. 1.7, sorry, I'm having trouble with my calculator. 1.717, okay, plus itself, or times 2, plus 17 is 20, and I'm going to round it 0.4 inches. That's the width. And then the length was 12 plus x plus x. So again, I'm going to use my big decimal, 1.7117 times 2 plus 12 is 15.4 inches. And that would be my answer. Now, sometimes you will get two numbers, but without fail, one of them will do something weird, like create a negative length somewhere, and that's not possible. So it's pretty easy to tell the difference. Okay, so that's the photography one. Okay, question number 2. Okay, so for question number 2, you need to know that rate of an object moving, or its speed, times the amount of time it is moving equals the distance it will cover. So question number 2 says, Callie left the White House and traveled toward the lake. Nadiba left 1 hour later, traveling 15 miles per hour faster in an effort to catch up to her. After 2 hours, Nadiba finally caught up. What was Callie's average speed? Okay, so whenever you have two objects that are going to catch up with each other, if they're starting from the same place, it means that to catch up with each other, they have to have gone the same distance. If they start at the same place and they catch up, their total distance for each of them should be the same. So when you're doing this style of question, the easiest way to do it is to make a rate times time equals distance chart, one for each of your travelers. So I'm going to have Kali, and the second one, Nadiba, I think is how you say that. Okay, so it says Kali left the White House and traveled toward the lake. Okay. We don't know her rate, so we're going to go R sub K, Kali's rate, times Kali's time, T sub K, equals, we're just going to say D for distance, because for them to catch each other, they had to both have the same distance. It says that Nadiba left 1 hour later. So that means that her time was, because she left 1 hour later, her time was shorter than Kali's time because she left an hour later. So we can represent Kali's time and then subtract 1 hour because Nadiba left an hour later. It also says that Nadiba was traveling 15 miles per hour faster than Kali. So if we take the rate of Kali, we add 15 miles per hour, we have the rate of Nadiba. And then, of course, they both catch up to each other, so they go the same distance. So what you have to do is when you're writing rate and time, you have to replace enough variables that you get yourself down to only 2. Now, if you look at this, we still have 3 variables, R, T, and D. The thing is, since they are equal to each other, since they both travel the same distance, we can actually set their equations, R, T, equals to this one, and I'm just going to change it to R because it's all in terms of Kali anyway. R plus 15 times T minus 1, we can put them equal to each other. Now there's got to be one more thing. I see the part. After 2 hours, Nadiba finally caught up. So her total traveling time was 2 hours. So she did leave 1 hour later, but her total time was 2 hours, which means that Kali's time had to have been 3 hours. Now we're down to 2 equations and 2 variables. This one we only had 1 equation with 2 variables, so it wasn't solvable. This one is though. So we have R times 3 equals D, and we have R plus 15 times 2 equals distance. Now from here, you can, I would probably recommend substitution method. Since D is equal to 3R, you can go ahead and sub that in. So you get R plus 15 times 2 equals 3R, and then keep on going. And solve for R, substitute back in, solve for D. Okay, we don't have time to go completely through the problem. The main thing is I wanted to show you the approach, how to make a rate times time equals distance chart, how you substitute in information that you're given. Some tips. In this one, they were both traveling the same distance, so they both equaled D. If you have them meeting up, let's say that Kali goes this far and Nadiba goes this far, and they meet up. If they meet up, they didn't travel the same distance because one traveled faster than the other. So you can't say that their distances are equal. You can say, though, that their distances add up to a total distance if they give it to you, like 150 miles. So what you can do is have Kali's distance plus Nadiba's distance equal 150, and that will give you something to substitute into the chart. This works the same way if they're going away from each other. So if Nadiba goes one direction, Kali goes another, and then they stop, you can still say that Nadiba's distance plus Kali's distance, D sub K, Kali's distance, add up to some total, let's say 170 miles. And again, the purpose is to give you something to replace one of them with in the actual chart. All right, so that is how you do a rate times time equals distance problem. Hopefully this doesn't look totally new. It's a style of problem you should have done in Algebra 2. Okay, question number 3. The first leg of a right triangle is 7 more than the second leg. The hypotenuse is 8 more than the second leg. Find the lengths of the sides. Okay, so the minute you hear right triangle, you're looking for a Pythagorean relationship. If you remember the Pythagorean theorem, given a right triangle and side or legs A and B and hypotenuse C, leg squared plus leg squared equals hypotenuse squared. Okay, so in this problem, it says that the first leg of a right triangle is more than the second leg. So let's just draw this. Okay, so the first leg, let's call that one A. The first leg of a right triangle is 7 more than the second leg. So this side is A plus 7. This leg is 7 more than that leg. The hypotenuse is 8 more than the second leg. So A plus 8. This is assuming we call this one the second leg and this one the first leg. Now we take these lengths, put it into the equation, and you get A squared plus A plus 7 squared equals A plus 8 squared. And then you do a whole heck of a lot of multiplying out. This is A squared plus 14A plus 49 equals A squared plus 16A plus 64. I'm going to skip a few steps, ... You end up with A squared minus 2A minus 15 equals 0. This is a quadratic, so you can factor quadratic formula or completing the square. You get to pick. As it is, it factors into A minus 5 times A plus 3. And you solve, and you get A equals 5 and A equals negative 3. Now, you can't have a negative length, so A can't be a negative 3. So this one turns out to be extraneous. And from there, you can put together the lengths of the triangle. One of them is obviously A, which is 5. The other one is 7 plus 5, which is 12. The other one is 8 plus 5, which is 13. And they didn't give you any units, so it's just units. So that's how you do a Pythagorean relationship. You do two sides in terms of the third one, and then you substitute into the Pythagorean theorem. Okay, let's do number 4. Number 4 says, Leslie, standing on top of a cliff, throws a rock upwards at 15 feet per second from an initial height of 50 feet. How high is the rock after 2 seconds? Okay, so to do this problem, this is a thrown object. And this particular approach or equation is just you've thrown it up and it falls down. There's no curvature to it. We'll do those later. So your equation is s equals negative 16 t squared plus v sub 0 t plus s sub 0, which looks really complicated, but it's actually not. T is the time in the air. Y is the height at time t. So you can calculate as many y's as you want, depending on how long it's been in the air. V sub 0 is the initial velocity. how high did you throw it, or how hard did you throw it when you were throwing it straight up? And then y sub 0 is the initial height. And whenever you see the initial, that's when time equals 0. What's your starting stuff? Okay, so that is your basic thrown object formulas. Now you get to enjoy the absolutely atrocious artwork that I'm able to do. So you've got a cliff. It says she's standing on top of a cliff. And here's the person. And she throws the rock upward. So it's going to go up for a while, and then gravity is going to take over, and it's going to fall straight down. And it says she threw it upwards at a rate of 15 feet per second. That was its original force being thrown up. And it says that she is on a 50-foot cliff, which means the rock started at 50 feet. We can assume that her body height is negligible unless they give you the height. So you always assume it's measuring from her feet. And it says how high, they want to know how high is the rock after 2 seconds. So at t equals 2 seconds, they want to know y, which is the height at 2 seconds. Okay, so let's fill this stuff in. Oh, I put y instead of, and y sub 0. Your book says s and s sub 0. Some books use y and y sub 0. It doesn't affect it. It's the same thing. So whether this is s sub 0 and this is s, it's still the height and the initial height. So I put both of those on there. So if they throw a different formula at you, you're used to seeing it. Okay, so we want the height. We'll say s. And it's after it's been thrown for 2 seconds, so 2 goes in for t, plus the initial velocity was 15, times how long we want it thrown, which is 2 seconds, plus the initial height. Well, it started at 50 feet. So that is your equation. Then it's just plug and chug. Be sure and do 2 squared first. 2 squared is 4. 4 times negative 16 is negative 64, plus 30 plus 50, and we get 16 feet. So it's 16 feet off the ground after 2 seconds. That would be your answer. So really important is this thrown object formula. And it doesn't change unless you're throwing an object at an angle, and we'll do that later in the year. Okay, last one. Question number 5. And this is a style of question we've done before. This is one of those consecutive number questions. And it says, when the smaller of 2 consecutive integers is added to 4 times the larger, the result is 79. Find the 2 integers. Okay. So I'm going to call x the smaller integer. I'm going to call y the larger integer, just so I have them together. Now, when you add this stuff up, the result is going to be equal to 79, but we have to figure out what we're adding. It says when the smaller of 2 consecutive integers is added, so x plus is added to 4 times the larger, 4 times y, the result is 79. Now, if that's all you do, you're in trouble because you've got one equation and 2 different variables that is not solvable. So what we need to do is figure out a way to replace one of them. Well, when we're talking consecutive integers, it means whole numbers. And it also means whole numbers that are next to each other. So if one is 5, the next one is 6. So if we don't know the first number, let's call it x. To figure out the second number from the first number, we need to add 1, just like we would add 1 to 5 to get 6, 6 being the larger one. So y is the larger number. We can replace y with x plus 1. Now we have an equation that is solvable. One equation, one variable. So start by distributing the 4. 4x plus 4 is 79. 4 plus 1 is 5x. When you subtract 4, you get 75. So x is 15, which means that the next number would have to be 16 because x was the smaller one. And there you have it. Okay, as you're doing your story problems, try to identify which pattern it's following and use the same approach for that one problem type. If we were to put together all the story problems you're expected to know for the SAT, there's really only about 15. And right now we just did 5 of those 15 that you need to know. So once you've learned the problem types, really you can tackle any problem that is similar. Have a good afternoon.